Hello, this is Mrs. Doro, and today we're going to look at how to use our periodic table, what the numbers mean, what the decimal numbers mean, and how we can find out information from it. We're going to learn how to find protons, neutrons, and electrons. We're going to talk about things called ions and isotopes. Please remember that if I put a star by it, see if I can make a star, and or underline it, that I would like you to copy it down. Okay, our first look at the periodic table is that we have something called an atomic number. And that would be the top number, the whole number. If you look at hydrogen, it's going to be that 1. Or on beryllium, Be, it's going to be the 4. And that's always a whole number. And it's, as you notice, it's always the smaller of the two numbers that's in that particular spot. All right, so let's just take a look at carbon because it is highlighted. We've got an atomic number of 6, and we have a chemical symbol. They all have names. Carbon symbol starts with a C. Most of them are going to be the first letter or the first two letters. You'll notice that some of them aren't necessarily the first two letters. Manganese here is Mn, and gold is Au, which you wouldn't think for gold. Silver is Ag, so you're not always going to have the first two. All right, the name is the official name given to the element. It can be named after a person or a place or something about the element. This one's carbon, so I'm just going to write carbon. I can write that. There we go. And average atomic mass, this is how much an average atom weighs. Now, they're not all going to weigh the same, but this is the average if you were to take a bunch and put them together. In this case, it's 12.011. All right, let's look at atomic number and what it tells us. Atomic number is very important. As you notice here, I'm going to star this whole thing and I'm going to kind of highlight it, is that it never changes. The protons are what you get from the atomic number, and that number is never going to change. The number of protons is going to stay the same. It also tells us the number of electrons that are outside the nucleus. Remember, protons are inside the nucleus. Protons have a positive charge, and they are inside, and electrons have a negative charge. That's why I'm going to draw a little negative, and they are outside the nucleus. My pen doesn't want to write today. All right, so that's outside the nucleus. So let's take a look. Basically, you're just going to look for the atomic number. All right, so can you find the number of protons and electrons for a magnesium atom? And can you find the number of protons and electrons for a boron atom? I'm going to stop it, and then I'm going to write the answers. Okay, let's take a look at the answers. Magnesium is number 12, so it always has 12 protons. And in this case, because it's an atom, it has 12 electrons. Boron, it's number 5. It's B, and so it is going to have 5 protons because it is number 5. And in this case, it has 5 electrons. Okay, let's look at average atomic mass. Here, there's my little star. The average atomic mass of an element is the sum of the masses of its isotopes, and we'll talk about what an isotope is. But basically, the atomic mass is made up of protons and neutrons, and if you took like 3 different carbon atoms, they would not all weigh the same. One might weigh, let's say, 11.2, one might weigh 12.1, one might weigh 13.8. You take them and you average them, and this 12.011 that you see down here, that's an average for all of the atoms that they found. That's about what they weigh. That doesn't mean that every single one's going to weigh that. The atomic masses are in decimal if you take a look, and so I will have to give you the mass of the atom or the isotope we're using. We're going to come real close. If it's an atom, we're going to come to within half of a gram of what that is. Let's just say that was 39.098. It's actually AMUs. So we're going to come within a half of that to make it an atom. All right, isotopes will be larger or smaller. They'll have a different mass. So we'll talk about that a little bit later. You will see atoms written a bunch of different ways. So I'm going to show you all the different ways that you may see them. Our most common ways they're written on the periodic table is kind of how you see them right now. You'll see them written like carbon. It'll have a 6 over it, and then instead of the decimal number, they will give you a number, a whole number, 12. They'll round it, basically. I'm not telling you to do that. I will give you a number. So you'll see a 6 and a 12. You may also see them switched around. You may see for fluorine, let's take a look at fluorine. If you notice fluorine's number 9, you may see the 9 down there. And you may see the mass, which is around 19, up top. It can be on top or bottom. It doesn't matter. What you need to know is that the atomic number is going to be, atomic number is the smaller of the two. All right, and mass is the bigger of the two. You may also see them written with just the mass. So let's just look at beryllium, Be. They may just put a dash and a 9. That doesn't mean it's atomic number 9. You have to look at your periodic table and say, okay, Be, it's atomic number 4. So that 9 is its mass. I would also like you to write down these examples here so that you can have an example of how each one is written. So in case you come across something and it's written kind of weird and you don't know what to look for, you have the examples. Okay, here we're finding neutrons. To determine the number of neutrons of an atom, first you have to find the mass, then find the number of protons. You're going to take the mass and subtract the number of protons, which we know is the atomic number. And this will give you the number of neutrons. Finding the number of neutrons for neon. I gave you neon 20. All right, so we're going to look at neon. Neon is atomic number 10. All right, so that's how many protons it has. And we know it has a mass of 20 because I gave that to you. All you're going to do is subtract, and that's going to tell you that it has 10 neutrons. All right, that's pretty easy. What you need to remember is that protons and neutrons equal the mass of an atom. So it's not always going to be what you see on the periodic table. All right, so if you see something for neon and ends up being, let's say, a mass of 22, that doesn't mean it's not neon. It's neon, its mass can change. It's the atomic number that never changes. Okay, here's some practice for you. I would like you to find the protons, neutrons, and electrons for helium, calcium, and chlorine. So stop the video and do that now. Okay, hopefully you took a minute and did this in your notes. And I am going to be looking for this practice that you actually did this. If you look at helium, it is number 2, so it has 2 protons, and it has 2 electrons, because it's number 2. And then look at the mass I gave you was 4. 4 minus 2 is 2. Calcium is number 20, so the protons and electrons, notice they are the same. In each one, for an atom, you're going to have the same number of protons and electrons. For calcium, we gave you the mass of 40, and all you have to do is subtract mass minus number of protons. 40 minus 20 is 20. And for chlorine, it is number 17. So we have 17 protons and 17 electrons. Math is a little bit different. You notice the numbers were the same for helium and calcium all the way across. But for here, 35 minus 17, the mass minus the number of protons, it's going to give us 18. Here we're going to talk about what an ion is. I'd like you to write down the definition for an ion. An atom, but something's happened to it. It's lost or gained an electron. Sometimes atoms have to give away or accept an electron to be happy, and we'll talk more about that later, but they give away and they take from other atoms. When this happens, your total number of electrons changes. So it now has what we call a net electric charge. Okay, so I want you to understand that when it gives away or gets one, your element will have a new electric charge. And you'll be able to tell it's an ion because it'll have something on it called a charge. A +1, a +2, -3. It'll have a number and a charge on it. So what I want you to do is I want you to look at this example right here. This is going to be potassium 39. So we're going to write K. You probably wanted to write a P, but that's phosphorus. And you'll see it written K39 with a +1. That's how you know that it's an ion. It'll have a charge. It'll say +1, -1. So we're going to find the protons, neutrons, electrons. So let's look over here at potassium. How many protons does it have? Look at its atomic number. It has 19. Neutrons, we're going to take the mass, 39, and we're going to subtract the number of protons, 19, which gives us 20. So we're going to write 20 here. and then we're going to do electrons. Now, normally, you'd have 19 electrons, but that plus 1 means that you have basically an extra, not an extra, but you have more positives than you have negatives. So we're going to do the opposite of what that charge says. If that charge says plus 1, I want you to subtract 1 from your protons, and that means you only have 18 electrons. So let's take a look at that. 18 negatives, because electrons are negatives, plus 19 positives. So what does that give you in net overall charge? If you have an 18 and you take 18 away, it gives you an overall charge of plus 1, and that's why we have this plus 1 up here. Okay, here we go. Here's some practice. I expect to see this in your notes that you've tried this. This is going to be CO, which is cobalt, 59. You're going to find the protons, neutrons, and electrons. Iron, 56. Bromine, 80. And notice they all have charges. I want you to stop the video right now, and I want you to do these on your own. Okay, here we go with the answers. If you look at cobalt, cobalt is number 27, so it's 27 protons. It would normally have 27 electrons, but this plus 2 tells me I have 2 more protons than I have electrons, so I'm actually going to subtract 2 from 27, and that's how I got the 25. And I took 59 minus 27 and got 32 for my neutrons. Iron, number 26, normally would have 26 electrons and protons, but I have a plus 4 charge, so I took 26 minus 4 to get 22. To get the neutrons, I took the mass of 56 and I subtracted my protons, which is 26, gives me 30. Bromine is number 35, so I had 35 protons. Normally I would have 35 electrons, but notice it had a minus 1 charge. So I'm actually going to do the opposite of what it says. Instead of minus 1, I'm going to add 1, and that is how I got 36. And for my neutrons, I took 80 minus 35, gives me 45. Alright, let's look at isotopes. An isotope, and I want you to copy down the definition of an isotope, so I'm going to kind of circle it, is an atom with a different number of neutrons, and therefore a different mass than the mass found on the periodic table. You can tell if an element is an atom or an isotope of the same atom by finding the number of neutrons and comparing it to looking at the mass and the protons, what it says on the periodic table. Alright, so let's take a look at this example. I give you nitrogen, and I give you a mass of 16. If you look on the periodic table, it says 14. So right away, I know this is an isotope because it's not the same as what's on the periodic table. It should come within about a half of what's on the periodic table. So if it's going to be the atom nitrogen, it should be 14. If it's not the atom nitrogen, it won't be 14. It'll be 15, 13, 16, something that's not 14. So let's take a look. Nitrogen is number 7. So it's 7 protons. There's no charge, so I have 7 electrons. Whenever you have no charge, protons and electrons are the same. Neutrons, I'm going to take the mass, 16, minus 7. I'm going to get 9 neutrons. Now I know this is an isotope because of this mass is different from the one on the periodic table. The one on the periodic table is about 14, and this one says 16, and that's how I know it's an isotope. Okay, I'd like you to do these problems in your notes, and I want you to find the protons, neutrons, and electrons, and then tell me if it's an isotope or if it's the actual atom on the periodic table. So take a minute, pause this, and do that. Okay, let's take a look at our answers. Boron, protons, neutrons, electrons, there's the answer, and this would be an atom, because if you look at boron, the mass you're given, 11, is within a half of what's on the periodic table. It's 10.8 on the periodic table, so 10.8 compared to 11. That's within a half. Zinc, it is number 30, and if you take a look, the mass was given as 65, and that's what's on the periodic table, 65.38. That's within a half. So that's an atom. Sodium, Na, is 24 is what's given to you, but it says on the periodic table 22.9. That is not within a half, so that would be an isotope. Gold, Au, is given as 197, and on the periodic table, it's almost 197, so it's within a half, so that would be an atom. Alright, so I want to see these examples, and I'll be looking for these when I check your notes. Thank you, and have a good day.